Good evening, this is Joseph Jones. Today's topic is internal combustion engine. I have done my mechanical engineering and master's in thermal engineering. So today's topic is internal combustion engine, where we will be looking out what are the basic principles and applications of internal combustion engine in our daily life. Now let's start with the learning objectives. To learn basics of heat engines. Now IC and EC. So IC stands for internal combustion engine and EC stands for external combustion engine. IC engines construction and component materials and the various nomenclatures of engine applications. Now let's see this figure where the car is there and it has an internal combustion engine inside it. That's where the car is moving. Whenever we uh, a petrol or a diesel inside the car moves on. So how it is moving, let's see. What is an engine of a car? So engine of a car looks like this, which has various components. We will be looking out. This is a four-stroke petrol engine. And now, what do we mean by engine? So a machine which converts chemical energy of fuel into mechanical energy. So what is the chemical energy here? Here chemical energy is the petrol or diesel and the mechanical energy, that is the movement of the car. How many types of engines are there? There are two types of engines. One is internal combustion engine and one is external combustion engine. And let's see what is an external combustion engine, where the combustion is taking place outside the engine. So there you can see the steam engine where the steam is produced somewhere and it is used, steam's work is used here outside. But as compared to that, we look at internal combustion engine like car engines. The combustion takes place inside the engine and the work is also be received through the help of a piston. So in the diagram, you can see both have a piston, but the combustion taking place is one is for external is outside and one for internal is inside. So what do you mean by internal combustion engine and what are the functions of internal combustion engine? So if you put a petrol inside a car, what it happens is it converts the chemical energy into, of the fuel into heat energy, and then the heat energy is converted into mechanical energy to perform useful work like this. So the chemical energy is converted into heat energy. First it burns and then it converts the heat energy into mechanical energy. Let's see what happens. There are types of engines. How many types of heat engines are? So there are two types of heat engines, external combustion and internal combustion. So in this, the steam engines, the gas turbine, the Stirling engine are the external combustion engines where the combustion takes place outside, and the internal combustion like auto engine, which is also known as petrol engine and diesel engine and the vehicle engine. Now let's go for the internal combustion engine. What are the parts inside the internal combustion engine? So here we can see the main parts of the internal combustion engine. First is spark plug. So if there is a spark plug, it is a petrol engine, and if there is no spark plug, there is a diesel engine. Now it has two valves. That is, from the top view, it has two valves: intake valve and exhaust valve. And the piston has, this is part where the rings are there, it is a piston, and there are a lot of rings where to avoid frictionless contact. Now there will be a cylinder which is placed inside, which is the outer part of the body, and there is a piston rod which connects the piston and the crankshaft. So there is a connecting rod, that is a piston rod which helps to connect the piston and the crankshaft. Now let's go for the some terminology like cylinder bore. On the top view of the cylinder bore, that is the engine, where we usually call it as cc, the cubic centimeter of an engine, and the bore is the diameter of the cylinder. So today's if you go for a bike, pulsar or a KTM, you will see the CC of the engine. So that is means the bore of the engine, where the diameter of the engine piston is calculated. Now let's go for the piston and the engine displacement, how it works, what happens, and what are the terms used in the piston and engine displacement. Now you see the figure, there is a BDC. So this is a BDC where it is known as bottom dead center, where the piston will come to an end and it will not move more than that. The same way there will be a TDC, that is top dead center, where the piston will stop moving ahead. So this is the 2 point where the engine piston is working. So the volume displaced as the piston moves from BDC to TDC is known as the volume displaced by the piston. Now, what is a compression ratio? So in order to understand what is a compression ratio, we have to know what is a TDC and BDC, what is the movement of the engine. So when I told you the BDC is the bottom dead center, where the piston is going to be resting at that position, and after that it will not move backwards. And TDC is the portion where it will be stopping at the top and it will not move forward. The red portion where the sign here is the compression ratio. The red color where I annotate is the top dead centers, and that is the compression ratio where the fuel is going to be compressed. The blue portion is the volume displaced. So the ratio of total volume in the cylinder and BDC to TDC. So if you want to calculate the compression ratios, you have to calculate the volumes and then the ratio of BDC to TDC. Now what is a stroke? A stroke is a linear movement of the piston from top dead center to bottom dead center. So the stroke, once the stroke starts from BDC, it will end to TDC. That is one stroke. And again, if the TDC to BDC, it is the second stroke. So the linear motion, up and fro motion, is known as a stroke. Now come to this portion there where the stroke length is given. So this is the stroke length where the movement will be calculated. Let's go for the four-stroke cycle engine operation. Now here the piston and the compression ratio is given. The red one is the compression ratio and the piston's sign is given. There is a connecting rod also, and there will be a crankshaft movement. Now what is a four-stroke engine? So four-stroke cycle engine requires 4 strokes of piston. That is, it should be moving up and fro 4 times, and only the piston will complete the 5 events necessary for engine operation. Now, what is one piston stroke? That is 1/2 of the crankshaft revolution. That means we have seen the crankshaft, it moves to 360 degree, and if 180 degree is given, then it is known as half crankshaft revolution. So 180 degree of the movement of the crankshaft is one piston stroke. That is, either the piston will go from BDC to TDC or the TDC to BDC. Now, what is 4-piston stroke? That is 2 crankshaft revolutions. That is, once the piston is moving up and down 4 times, then the crankshaft will be having a 2 revolution. That it will have 2 revolutions, 360 plus 360. That is 720 degree it will take. Now, what do you mean by 4-stroke engine? A 4-stroke engine has main parts where it has a spark plug, it has inlet valve, exhaust valve, cylinder, and the piston. Now, how it is going to be working, we will see here. Now, what first stroke is the induction stroke or the suction stroke. Here the inlet valve opens and the piston will move down. Just like the piston is moving down, it builds up the fuel, that is air fuel mixture, that is the fuel we are introducing, and it will take inside the fuel ratio, that is air fuel mixture. And that once the fourth stroke is completed, then the compression stroke comes and the inlet valve closes. Now, inlet valve closes, the piston will move up and the fuel air ratio is compressed. At the stage of compression, what will happen? The power stroke will be generated, the spark plug will burn, and this will introduce a power stroke, and the fuel inside the piston will start combustion, due to which the heat inside the piston will be more than that, and it will push the piston downwards with a powerful stroke. At that time, this stroke, the powerful stroke is stored in the flywheel. So the flywheel will be connected with the crankshaft, which will store the energy of this engine. And then the next stroke will be the exhaust stroke, where the exhaust of the engine, that the exhaust valve will be opening and all the burnt gases will be pushed outside through the piston. Just like when we have done the suction, it was pushing the fuel inside. Now in the exhaust stroke, piston will push the valve, push the compressed burnt air, and again it will throw all the exhaust valve. Now the exhaust valve is closed. Now again the induction stroking is introduced, and again the inlet valve opens, and so the cycle continues. So this was the working of a four-stroke engine, where we can see the engine is